So, we all know AI can write code, and it can do it at a terrifying speed. But here's the real question. Is it good code? Today, we are going to talk about how to get all that incredible AI speed, but without the chaos. We're going to look at how we can move from this fast, kind of intuitive vibe of AI-generated code to something that's structured, strategic, and, let's be honest, a whole lot safer. It's really all about turning that vibe into a blueprint.
All right, let's get right into it. If you look at software development today, it's kind of caught in this perfect storm. You've got agile methodologies pushing for more speed, faster and faster cycles, and then, bam, generative AI comes along and offers all that speed on a silver platter. But this creates a really dangerous dilemma, right? Are we just sacrificing quality and safety for the sake of going faster? You know, this classic line from Sun Tzu just hits the nail on the head here. AI gives us these amazing tactics. I mean, the ability to generate a function in seconds is incredible. But if there's no clear, human-led strategy behind it, all that speed is really just noise. And it's setting us up for some pretty major failures down the road. This right here is the heart of what we're calling the vibe coding problem. And that brings us to this idea of vibe coding. You basically tell the AI what you want in plain English, it spits out a chunk of code, and you just move on to the next thing. It feels incredibly productive, right? But what's really happening is that you're often skipping the careful, deliberate review process that's there to prevent disasters. It's an illusion of progress. And look, these risks are not just theoretical. We're talking about very real, critical security holes. Think about the Databricks red team finding AI just misusing Python's pickle module in really unsafe ways. We're seeing AI reintroduce old, solved problems like SQL injections. And if that wasn't enough, you're left with almost no useful documentation and a development pace that leads straight to what people are calling agile burnout. So how do we fix this? How do we get the speed of AI without all the risk? Well, the key, it turns out, is to completely reframe our relationship with it. Instead of seeing AI as a tool that just replaces us, what if we thought of it as a cognitive partner? And this leads to a really powerful idea from psychology: thinking fast and slow. Let's break this down. Think of the AI as your System 1 brain. It's incredibly fast, it's intuitive, and it's a master at matching patterns to generate solutions almost instantly. Now you, the human developer, you're the System 2 thinker. You're slower, you're deliberate, and you're capable of really deep reasoning and verification. Each of us has a superpower. And this is the most important insight. We don't want to slow the AI down. That's not the goal at all. We want to harness its speed. We use our strategic System 2 thinking to provide the guardrails and the direction for the AI's super powerful, super fast System 1 capabilities. It's not about control, it's about synergy. Okay, that sounds really good in theory, but how do we actually do it? How do we translate our strategic human thoughts into a format that a fast-acting AI can understand and actually follow without getting lost? Well, we need a shared map. We need a blueprint. And that blueprint is something called the Automated Code Meta Model, or ACM. Now, I know, the name sounds a little intimidating, but don't let it fool you. Just think of it as a really rich, multi-layered GPS for your entire software project. It's a map that both you and your AI agent can read perfectly. It becomes your shared language, your single source of truth. Now, this is what's so cool. The ACM builds this map in 5 totally distinct layers. It starts with intent, the why behind the code. Then it defines the behavior, the what it actually does. It maps out the structure, or how it's all organized. It then charts out the semantic layer, which is like this invisible web of connections and dependencies. And finally, it assesses quality, giving you a complete health report on the code. Let's dig into the first few because they're really key. First up is the intent layer. This is the why. What this does is forge an absolutely unbreakable link between every single piece of code and the original user story or business requirement that it's supposed to fulfill. This makes sure your AI never, ever loses sight of the real goal. So once we have the why, we move to the what, and that's the behavior layer. This layer defines what the code actually does in the real world. You know, what state does it change? Does it have side effects, like writing to a file system? It's basically the functional contract of the code, pure and simple. And then beneath the behavior, you've got the structure layer, which is the how. This provides a language-independent architectural blueprint of your entire project. All the modules, the classes, the functions. It gives the AI this amazing bird's-eye view of the landscape, so it doesn't have to read every single line of code to get its bearings. So how is this whole complex map actually created?
It's through simple annotations right inside the code, just like you see here. And this is where it all just clicks into place. You can see the direct link to a user story, a crystal clear description of its behavior, and it even declares its side effects. This is documentation that is alive, that is totally machine readable. It's a game changer.
Okay, so now that we have this blueprint, let's see how it creates a genuinely powerful collaborative workflow. What does it actually look like when a developer and an AI agent use this shared map to get real work done together? It looks like this. Instead of just fumbling around in the dark, reading thousands of lines of code, the AI agent first loads the ACM. It loads the map. Then it queries the map to find the exact code it needs, to understand all its dependencies, and even to assess potential risks. It reads only the relevant lines, makes changes with full awareness of all the ripple effects, and finally, it runs only the specific tests related to that one change. It's surgical precision, not a brute force attack.
And the real beauty here is that this isn't some radical new process you have to learn from scratch. This intelligent, focused workflow just slots directly into the standard agile development cycles you're probably already using. It doesn't replace them, it just makes them way smarter, way safer, and a whole lot more efficient. This metamodel is so much more than just a technical tool. It's really the foundation for a whole new philosophy of AI-assisted development. It's a philosophy that's built on a core set of principles for a safer, more strategic partnership with our AI counterparts.
These are the SAFE AI principles. It stands for strategic deliberation, attention to impact, freedom, and empowerment. And together, they create this simple but really powerful framework for building that symbiotic partnership between your strategic human mind and the AI's tactical speed.
And you can see exactly how the meta model brings these principles to life. That intent layer, it forces strategic deliberation. It makes you define the why. The semantic layer, which maps all the dependencies, demands attention to impact. And the whole model gives developers the freedom and the empowerment to guide, to verify, and ultimately to trust the work being done by their AI partner. So this leaves us with a really fascinating final thought. As AI gets better and better at the raw mechanics of just writing code, maybe the most valuable human skill is starting to shift. Is it possible the future developer is less of a coder and more of an architect, someone who masterfully designs the intent, the behavior, and the safety net for an AI to then go and build the future? Something to think about.